Welcome to the presentation of this IUI 2021 short paper by myself and Professor Funk. The paper is titled Towards Guidelines for Designing Human-in-the-Loop Training Interfaces. This paper is concerned with interactive machine learning, a field about which the 2014 paper by Almar and colleagues goes into detail on the still open challenges and opportunities for advancing the field state-of-the-art. There are two main challenges here that really motivated this pilot study. The first is a call for more principles and guidelines on how to design human interaction with machine learning. The second is about development of techniques and standards for appropriately evaluating that. IML offers a set of unique problems in the design space. Because there is a human with more agency in teaching the system, they can give more detailed learning input, which in turn trains the system faster. However, that more complex input also puts more strain on our user and subjects them to fatigue and the option of making more mistakes in the long run. It is thus important that we strike a good balance and instead measure the combined effectiveness of user and system working together on a training task. We investigated this relationship by constructing a pilot study in which users interact with a number of systems. The result of those interactions are used to construct a linear function that denotes interaction quality. Although this is not empirical evidence by any means, it is meant to provide an example of how we propose similar assessments should be shaped in the future. The method for our experiment put users in front of a furniture selection system, with the goal of getting a recommender system to recommend them a specific item, being a red chair. Users go through 4 different interfaces, evaluating them all after use. To poll their experience, we asked them to report effort using the task load index, as well as having them report interactivity and engagement on the same scale. We also measure the efficiency with which they complete the recommendation cycle, the quantitative values here being the number of clicks that they give and the time that it takes them to complete the task. The first interface they interact with is a very simple like or dislike screen in which they like the item based on how similar it is to the red chair. The second interface, however, has a lot more agency to it and allows users to enable or disable different features on the side of the screen and then like or dislike, telling the system what to take into account or not. Our third interface is a comparative interface that lets the user teach by picking the most similar option. This is basically a nearest neighbor scenario. And finally, fourth, we have a revision of the first interface in which users like or dislike the item, but the system has a conversational nature and asks them on the basis of what feature they made their decision. From our participants, we were able to gather qualitative feedback showcasing avenues for potential guidelines. The first of these is that room for richer expression is likely to deliver a better experience, as was reflected by our interfaces 2 and 3. Secondarily, participants mentioned that recalling information can be bothersome, because they are not always aware of what their prior reasoning was. Rather, they would prefer to supply information proactively. Third, participants expressed the fear of making mistakes and ruining their personal algorithm. That's why it's essential we provide a feeling that they can make no mistakes in returning inputs to our system. Finally, the difference between, for instance, in our first and third interface, we showcase that an increase in interaction time is not a necessity for an increase in quality of data, as the time of total interaction was similar. We show, also, how one can go about constructing a function to denote comparative interaction quality based on these experiment measurements, by asking users what their favorite systems to interact with were and combining that with efficiency. We can linearly relate those factors to Q, a representation of that interaction quality. It should be noted that the model provided is by no means empirically supported. However, what we do supply is a method of going about distinguishing interaction quality for systems. We would like to inspire others to investigate the exact relationships between the function parameters and the inclusion of more or different types of interfaces. Part of this non-definitive nature also comes from the limited number of participants, meaning there is limited predictive power in the study. Also, some participants had a prior understanding of ML, which could have shaped their behavior. Concluding, what we find is that interaction quality is crucial for training with the human in the loop, especially long term. It should thus be considered to define the quality using both the experience and efficiency of the interaction between system and trainer, and we propose a method of going about doing so being an interaction quality model. Also, the qualitative results gathered from participants in the study highlight potential avenues for investigation where we could learn more interaction guidelines for designing ML. Thank you for listening to this presentation. I'm looking forward to your questions.